Talking about vision. So I'm now looking at a crystal ball. What is the vision for the future? So a friend of mine blogs, yesterday I was wrong. I think I can say today I'm going to be wrong. Vision is always a difficult thing to talk about. I need to cover event-driven. Is that coming up? Oh, even the animations are working. Excellent. And talking about microservices. So now I'm getting into more of a narrow viewpoint. And then trends. What's happening in the current market? Where is technology going? Where are the demands coming from the business? And looking to the future. So again, looking back into that crystal ball. Before we look down into architecture and sort of constrain ourselves to some of the server side things, I want to talk about some of the things that Thoughtworks, a global organization, and I forgot to mention we're hiring. I have to do that because they let me come. I'd like to look at some of the macro trends that are happening that are driving IT changes. This is probably a little bit better, those lights are up there. So I want to look at macro trends. And the first one I'd like to explore a little bit is realities. Back in the mid-90s, there was a game called Descent. I don't know if anybody remembers it. And it was flying around the universe, and you would trade on planets, etc. And it was really quite good for the time. And then somebody managed to bring in a VR headset. And so you put this VR headset on, and you played Descent by looking up and down. And this spacecraft would fly around based on where you were looking, and you'd be able to navigate the universe. It was incredibly pixelated. There was also a delay. So as you moved your head, suddenly things would come into view. So everybody who used it got seasick, or airsick, or just generally travel sick. It wasn't really a usable item. Fast forward to about a month ago, UberConf in Denver, I met up with a company that was using some of the HTC headsets. And so you've got high definition virtual reality. And they'd done something that allowed you to explore source code in VR with these interesting cities and towers. And you could explore around, actually walk around in the set. You could pull out a whole package, explore the package, pull out a class, look at its technical debt, look at its complexity, look at the tests that are run against it, and then you could put it back and you could wander over somewhere else. And you could do that collaboratively. Two people in different locations could explore the same universe. So one of the realities that is changing is the idea of using virtual reality for enhanced interaction with things that are more intangible, like our source code, like the internals of a combustion engine. All of those things are starting to bring new ways of interacting. Augmented reality, the ability to place virtual objects inside the physical space, be it Apple's AR kit or Microsoft's whatever it's called. Those things can now place, I'll have a television there, please, floating in space in the middle of my lounge. Exciting areas for things like operations, being able to place your operational centers within your work environment, or within AR to be able to explore data flows within and visualize these things. So reality for us is, for human beings, is changing, and we're having an enhanced perception of things around us. Those are some of the trends that we've got in the interaction space, and those are going to start impinging on our architectures and the way that we build software, not only for the client, but also for all of those back-end supporting pieces. I don't think I need to dwell too much on the Internet of Things, but I now get to walk around a new city. So I was walking here this morning, and my wrist was buzzing. I still missed the turning, but it was buzzing to tell me I should have turned left. Things are becoming more interactive. From this point, I can lock my car. It's about 4,000 miles away. I can turn on the heating, and I can set the alarm in my home. All things that I can do over the network. As things progress, we can already measure the the amount of water in the soil, and anything we can measure electronically, we can now create a device for. And those are popping up all over the place, and there's things like Arduino. These things are proliferating, they're getting condensed, and they're being placed around us, being able to give us better location, better interaction. But most importantly, I think for us as software developers and architects, they're generating data. And they're generating that data in bite-sized pieces. And those, you might imagine, are events, point-in-time pieces of data about the things that we're looking to be interested in. I was really interested in the presentation just before lunch around healthcare and the application of intelligence for the enhancement of people's lives. And so the next thing, I think, in terms of trends, this is already becoming a bigger and bigger piece. I played with IBM's AI and Watson and so on a few weeks ago, and the ability to understand the way we want to communicate in terms of voice, in terms of text, is changing the way that we interact with the software around us. And we can now do things in a much more human-centric way than always dipping to the keyboard to type commands or pressing buttons. So the intelligence of those systems and the way that they are being used both for good and for bad. There are good applications in being able to recognize problems that people might be having, but there are also some of the what I think might be considered misuse in being able to characterize people, if you've been reading the press recently, of being able to recognize things that we as human beings miss in the swathe of data that is being presented to them. But generally, systems are becoming smarter. I think every organization with a UI is looking to add AI into that mix to be able to serve customers better, to be able to allow them to interact with the software as they might want to interact with a human being. I'd like to consider another direction, instrumentation of self. So again, this device that sat on my wrist, and I'm now wedded to it like my phone. I can't leave home without my phone. I had anxiety leaving it at the back. But these devices that we now wear are providing a huge amount of data about ourselves. This one has a simple heart rate monitor, which I occasionally look at and get worried about. But apparently I'm also not exercising enough. So there are all sorts of things, but those feedback mechanisms, those are now becoming part of our expectations. We're being instrumented, and the extensions of medical devices that are then collecting this data. There's so many things that we, as healthcare professionals, would like to know about our history. How did you get to this problem? And now we have abilities to mix various elements of AI, instrumented self, Internet of Things, to create all of these other interaction points that are all tied together and allow us to change the way that we interact with software, but also how that software can then interact with us to augment, enhance, and improve our lives. So these are some of the trends within the industry that we're within Thoughtworks are seeing, and I think I think you have to be a non-Twitter follower and not be on Facebook and probably not on LinkedIn to not miss some of these things. But these are seismic shifts in the industry. They are going to have new demands on the software that we build. In parallel with that are users' expectations. People are expecting software to be instantaneous. And so I'll pick on banking, I'm sorry, but I will pick on banking. And in banking, well, all of the bank accounts I have, there are probably other people disrupting the market. I can look at my balance as of last night. It will be the same for my mortgage account. Things close on a regular cycle, and that's predominantly historical, when banking hours would be from, say, 9 till 5 or 9 to 4, and then afterwards everybody would go through and they would work out the books and they would produce a balance, and that balance would be available the next day. Our software systems, unsurprisingly, support or mirror the approaches that we took in the non-software world, and we've perpetuated those. Now I think human beings are expecting different behavior. Why do I not get my instantaneous balance the moment I touch the card? And you probably can now. But the expectations of users are now instantaneous. I remember some time ago when probably the first web application that I was building, there was a website at the time called 15seconds.com. Did anybody else see that one? So the hypothesis was that if a web page didn't load in 15 seconds, then the user would go somewhere else. If you didn't surface your page in 15 seconds, you'd lost that potential customer. That was some time ago. 15 milliseconds is probably what my niece would expect when she goes to a website. If it's not there, she's a very instantaneous person. But she's grown up with that expectation. I press a button, it buzzes. I press this, it happens there. I tweet something, I expect somebody to reply. In her case, within a second, because she has a large social following. But generally, as we go through, the expectations of our customers are changing to more real time. They're expecting things to always be real time. And we mentioned earlier about outages, being able to upgrade software. We're moving into, we're already there, 24/7. People expect to be able to be working at night, gain access to systems. They're not expecting anything to pause. So those are some of the macro questions. As I mentioned, I had a whole bit at the beginning about interrupting me if you wish. As this is version 3, I can speed through and slow up and so on. So give me some real-time feedback as we go along. So macro trends, interaction, how systems are going to be interacting with us as human beings, how we're going to interact with them, and the intelligence that they have within them to change the responses based on a huge amount of data. Being able to predict what we're going to do next in order to already be there. So at 9 o'clock in the morning, I have a coffee. Maybe 9 o'clock in the morning, my coffee can be there warm. And preferably European coffee. I live in the US. I missed out a whole intro piece at the beginning. So I'm English, living in the US, and I really miss the bread. Lunch was fantastic, and the coffee most of all. And that's a good transition, or it's at least a transition from the macro trends. I'd now like to focus in on some of the more relevant micro trends. And I even had a slide to talk about that. Architecture is going through an evolution. The way that we present ourselves as software architects, software designers, and architecture in itself is evolving. The patterns that we apply are changing more rapidly, I think, than they have done in at least my career. And the architectures that we build are also expected to evolve. It's no longer acceptable to do the 5-year rewrite. Has anybody done the 5-year rewrite cycle? Every 5 years you rewrite the system? One person. Okay. I will put both hands up to represent the other people. Quite often we would build something and then we would recognize it would either turn into the big ball of mud, lots of connectivity, coupling, etc. Maintaining systems is probably one of the hardest things to maintain within an organization. I built something beautiful 10 years ago. It was absolutely glorious. But how do I know that the longevity is going to be there? New people came in, they didn't necessarily recognize the same values, and it would change and it would evolve over time. Evolution is great, But devolution is destructive, so applying old patterns to new pattern software. Quite often, systems degrade over time, and that gives you the maintenance curve. It gets to a point, new people come in and say, this is now legacy. Everything these days seems to be legacy, unless I write it. But I got a response. Good. So the whole cycle of legacy software is becoming untenable. The spiky investments from the business in being able to inject cash into the IT organization to build a new version, when we built the other one, and it was possibly some of the same people, is becoming untenable. So evolutionary architecture, I'll put in a plug for a new book coming out from some of my colleagues on how to create fitness functions around architecture so it can evolve within those functional parameters. Think guardrails, or something similar to guardrails that help people be guided in the evolution of the systems. And I think that's one of the things that is going to be coming into, or an expectation of software architecture and architecture itself to be evolvable. That ongoing investment at an appropriate rate, expecting those software assets to evolve and take on the new demands, and some of them I've just described. Focusing in a little bit more, because I am a server guy. I like building services. I used to be a UI guy before the internet, but I'm now more of a services guy. I like building services. And the first thing I want to do is make a call out to monoliths. I like monoliths. They're really simple for me to get my head around. You know, there's one thing, and I deploy one thing multiple times, and there's one database, and there's one API, and everything is in one place. They're not appropriate for everything, but quite often, building a monolith as your first starter can alleviate many of the headaches that you then need to, or expectations that you then need to put in place for something more like a smaller service. So starting point, some of the project track records that we've had, building and decomposing a monolith is a valid path towards a more deployable, updatable architecture. Well, if you're learning and building something new, I think there are a few hands who've done greenfield. Building something in a monolith, I know this is counter, it's not microservices, and I'm supposed to be talking about microservices, but sometimes using a monolith as a path to your design, they're much easier to refactor within a single code base. It's very easy to move responsibilities around between, oh, I need a new aggregate route. I can just refactor that. And doing that in an IDE within a single code base, within a single deployable artifact, avoids many of the things that you can then grow into later. So if you get a greenfield project and you're picking up Axon and the new event store, then consider starting off as a monolith before working on decomposing that into separate deployable items. Maybe you start off with one team, and as you break up the teams, that will be an appropriate point to decompose. On the subject of microservices, because it was in the title, and so I have to talk about microservices. In fact, I'm going to highlight that I'm going to be talking about microservices for one slide. Oh no, that was 4, sorry. So, James Lewis and Martin Fowler say, Martin Fowler says naming things is really, really hard, and I've got a couple of things there. They came up with, I think James Lewis came up with microservice, but I could be wrong there. But if your monolith is 1 million lines of code, then your microservice is 1, which is not really good. So I don't think anybody really likes microservice anymore, other than a word in our dictionary to explain something that we mean, which is something that fits into a bounded context, defines and lines up with a business. And this has been mentioned a few times today, and I've got to emphasize it some more, that a service or a microservice with a small mu The most important thing is that it lines up and bounds a business function or provides business context. This is counter to all of the adventures in SOA land that we enjoyed a decade or so ago, where we would have things more like CRUD services, more on CRUD later. So creating the appropriate context. Coming in later in the day means that I'm doing somebody else said this earlier. So a service doesn't typically work in isolation. There are other pieces, there are collaborators that a service needs to interact with. And those collaborators can either be a synchronous call, which Prem was talking about earlier, or we can look at other things. So I think one of the interesting aspects of microservices, when you start having more of them, when you start off with one microservice, you could say it was a monolith. Oh, okay. But we now have 2 or more in our ecosystem. And let's say we have 2 services, and each one can support 1,000 requests per second, which is pretty good. Maybe they're within a cluster, which means they can accept more. If we do a synchronous call between the 2, let's say it's an authorization. So every time we make a request, we've got to call over to another service and say, is this user permitted to do this? Are they entitled to look at this piece of data? Are they entitled to do a modification? Then we start getting heat within our architecture. So cross-calling between microservices creates a very interesting performance scaling equation, because you have to know your dependencies and which calls make a call over here. And the feedback loop is actually quite difficult. How do you scale something when the load is variable and could be immense if everybody calls one method or function or endpoint, but it's not if they don't. So you can end up with scaling the dependent service orders of magnitude, or at least twice ON, to all of its callers. And this becomes a serious performance problem. One solution to this is to introduce an orchestration layer similar to the API gateway, but with more control over the overall process. Anybody who's implemented an ESB knows that the simplest way of solving a problem is to just solve it in the ESB. And so they leach business logic because there is an urgent problem, we've got to pragmatically solve it, and so we do that, and then we've got on to the next urgent thing, and we leave that in the higher levels. So similar to other patterns where there is an orchestration layer, and I'm not calling out ESBs in particular, you could do this with a simple reverse proxy, but as you add in those capabilities, that becomes the hot element, and it starts leaching the business logic up through. So if those aren't the answer, what is the answer? How do we make sure that 2 things work well together? The orchestration layer is similar to a conductor. You play, we hear the music. Choreography is more like dance. Because someone moved, another element moved. And in choreography, it's about exchanging state through some level of asynchronous messaging probably, that allows each party to be independent. And this is where the asynchronous message transfer allows things to operate independently. Data-driven. Another trend is some of the things that our user interfaces are expecting and our systems. I spoke about my niece. She'll kill me to know that I've mentioned her, but I haven't given the name away yet. Our systems need to be responsive, but they need to be responsive under varying elements of load. So we're expecting our systems, whether it's 1 request per second, 1,000 requests per second, if you're Twitter, several million requests per second, though we are expecting our systems to respond, to always be able to come back and respond to our requests, whether it's a query for data or a command. We're expecting them to be able to respond to what's going on. We're also expecting them to be resilient. And I think this is something that is just starting to become one of the most important elements, particularly if you're in the DevOps space or SRE, getting systems to be reliable and resilient. Comparatively, it is very easy to build a system which calls another system, and that other system always behaves well. If you never get that unexpected connection that never actually completes, if you always get, I'm happy to fulfill your request, and everything is good. It's much harder working in the real world where just about everything seems to be out to get you, where firewalls don't complete connections to the ongoing service, don't like the content and throw it out and say, I didn't like what you were talking about, somebody upgrades a version and an API's changed. Being resilient to unexpected behaviors, to be able to recover from unexpected failures in availability, and to be able to present a responsive message to the consumer or to the customer is key. How am I doing on time?
10 minutes.
Excellent. I can finish. I should have mentioned another first. This is the first time I'm presenting this, and I got lost on my time period. Third part, elasticity. We need to be elastic to demands, to be able to shrink down when we're not needed and to scale up. Cloud, computing, being able to do that, but being able to do that in a predictable way that maintains our responsiveness. CFOs do not like large bills for unused assets. So being able to be responsive and appropriate in our costing and elastic then is a key part. I don't know if people are starting to recognize what this picture looks like yet. Exactly. So message driven, being able to exchange things interactively brings us to the Reactive manifesto. These aspects, and it's all supported by message-driven architectures, where messages are exchanged, that gives the isolation that has been talked about a number of times today, allows us more likelihood of being able to be responsive to queries because we're isolated, we have all the data that you need, that we're able to be resilient, and that we're also appropriate for the cloud with elasticity. Okay, so I have to give a shout out to Martin. I'm just going to do my test. Oh, look. Okay, this is me playing with a new toy. Okay, so Martin coined the term event carried state transfer to describe a particular type of event. I think it's a horrible name, but naming things is hard. He also coined that. Naming is one of the hardest things. I'm not really a great fan of that, but I can't think of anything better. So I'm looking for people to come up with a better way of describing the events that carry state. And event carried state transfer fills in all of those gaps, unfortunately, but it doesn't really work as a phrase. Now that we've named it, we've got events, we now need to name the events. So I'm going to take us on a little bit of a tangent rant. So, small thing, events are facts at a point in time. I think everybody was agreeing with that this morning, so I'm going to move rapidly on to, it's very tempting to, who's done REST endpoints? Everybody. REST is CRUD, create, read, update, delete, and when you think about entities and aggregates and aggregate roots, you think of the life cycle. I create one, I update one, and I delete one. So in CQRS, you've got your create, your updates, and deletes. I'm leaving out read in terms of life cycle because you can query that, which unfortunately means you get CUD, which is great for bovines. This is a water buffalo, but not so great for software. When naming events, create customer is a really nice thing. CFOs, again, would love us to be able to create customers. But we can only create, we actually create records that represent them. We don't create the thing. And one of the things I noticed, if you go back to the paper-driven systems that I mentioned we've mirrored, going back to those helps. You get a new customer registration or a new customer application, or you get an address amendment. Those things are in languages, all of our languages. So I would encourage you to create, not so awful, but as you move on to update, it becomes very easy to, talking about ubiquitous language, it becomes very easy to say everything is an update event. I update address, I update name. And then it's very easy to say, well, I'll just have a single update event, and I'll put all of the data in the event. And so I'll just fire one event, because one event is easier to handle than 50. But then, marrying that with domain-driven design, you start losing the richness of the business language. And then you have to start routing it based on the data that's within it. And the path, the reason I mentioned REST being I create a document, I update a document, etc. I do a post or put, and all of those things. We start thinking about things in terms of resources. And CQRS or commands are not resources. They are a command, and we should treat them with the respect that they deserve. So that's my sort of rant, and feel free to beat me up later at the back. I think I've got some limited time, so I'm going to run through this. Monitoring trends. Monitoring is becoming more and more critical. I just want to touch on a few things. Just looking at the stack that we have to manage now, everything from infrastructure as code through to our client applications and even beyond that, where we've got data coming out of each of these levels. On the left here, I've got the monitoring piece, and on the right, there's then the various things that are creating the data that we then need to manage. The whole middle section, with asynchronous messaging, we now have the consistency conundrum. What's the right level of consistency? How do we maintain that? What are our SLAs? It's a really tough problem to be able to know when things are consistent within an individual transaction. Forget the system. Overall, all of those things, at any point in time, it's inconsistent. But you can be consistent within for a user or for a particular system. Let's just go through this. I want to get to the next bit. I shouldn't have put the animations in. So one of the trends as well is that tracing is getting unified, and there are now initiatives like open tracing that gives standards for trace generation and trace consumption. And that's nice as we get more and more mature. These things are becoming institutionalized, and we're getting more and more tools. I was surprised to see in this space that there were about 15 different providers now, all supporting open tracing, which now means we can up things. So in summary, oh good, this didn't have an animation. It would be terrible to walk through each of these lines. So just to recap, we start off with realities. Those realities are increasing the ways that our people are interacting. They're generating volume. They're contributing to scale. Things in particular, the Internet of Things, is going to massively explode the data items that we need to store. So innovations within an event store, being able to capture and manage millions, billions, and what's the next one? Trillions. Made that one up. You can thank me for it later. I named something. So as we get petabytes of data, I remember petabytes, as we get more and more and more of data, we need better ways of managing it. We need to be able to look back at history, but we also need to be responsive. Intelligence. Applying intelligence, the intelligence systems will need commands to execute. What's the right thing to do at this point? I'll issue a command, which then it gives us a response. Expectations. We're expecting things to be resilient and responsive. On the right-hand side, command, query, CQRS, the separation piece ties neatly into many of the challenges that we're facing in the middle around volume, scale, and resilience. By separating the command side from the query side, we can scale those independently. Their characteristics are inherently different. By having asynchronous messaging between the two, then allows us to decouple and change the flow. So the answer is message-driven or event-driven. The future, just about every system is now moving towards being event-driven. Legacy system integration into service communication, everything is being decoupled through messaging. Messaging is going to be the core thing for architects to be able to incorporate into their systems. Thank you very much.
So I definitely want to be load testing our event store with quadrillions of events. That would be fantastic. So if you can recommend us on how many zeros that exactly is, that would be wonderful.
Like the word, I'll make it up.
So do we have any questions? Who dares? Yes.
Thank you. Thank you, Graham. Is there a tension between responsiveness and the separation? Right, so in other words, responsiveness versus eventual consistency. Experience recently, so many websites, for example, right, web applications that have gone to asynchronous JavaScript on the client, so many of them work so poorly, it seems.
In terms of being responsive?
Oh, yes, yeah, and in terms of you click on it and it doesn't work. And then, oh yes, yeah, it's trying to, it's invoking a handler and trying to talking to the server, and the server is slow. Deliveroo is a most recent culprit.
So I think the usual UX answer is, but you saw the spinning wheel.
No, it doesn't actually.
But, so, absolutely. In terms of, I think that then talks to performance, which I left out. How quickly things are being processed through. The usual UX excuse is that I'll present a spinning wheel, so you know something is happening, but you don't know when it's going to happen. But at least you can be happy watching the wheel. That then talks to, I think, the capacity and the performance of the components to deliver a reasonable user experience. So I think there is a tension. I'm not sure that we've actually solved all the way through. Talks to capacity and a number of other elements, and something to be monitored about how responsive we are in when do we take away the spinning wheel, and do you need to see the spinning wheel at all. But overall, I would, as a consumer, prefer to see a spinning wheel than I would the bar at the top saying loading page and stuck. So I think there are still some challenges we need to do in reconciling the non-deterministic nature of asynchronous processing with the expectation of the consumer that it's instantaneous and transactional. And those do need to be reconciled.
Right, but the trade-offs are worth it, right?
The trade-offs for the organization are definitely worth it in terms of elasticity, and although it does make the architecture more complex to begin with, so start off with a monolith and decompose. But yes, I think organizationally it means that you can cost effectively, whatever your scale you're at, be able to deliver service. So.
Any other questions? In that case, Graham. Oh, no, was he too late? Was that before the bell? After? Oh, let's give him a chance.
I'm a bit surprised you didn't mention serverless. Yeah, it may be just a small microservice or micro nano-service, but what do you think about this trend, and will it eventually consume everything? Or
so Mike Roberts is a good friend of mine who's currently doing a lot of work in serverless. I think it's a very interesting direction. I did think about including it, but I think each of those topics is worth a conference. And I thought, I'll stay away from serverless. I want to concentrate on smaller services, asynchronous processing, how it fits in with this conference on Axon and the importance of event sourcing and messaging. Serverless is an interesting way of handling commands, particularly. And so there may well be some hybridized architecture. If you want to hook up an Axon service to Alexa, you'll have to go through an AWS serverless function. I'm not clear yet how sophisticated the functions are going to be in comparison to the things that we now need to do in the back end. The other thing I didn't mention was streaming architectures. And that's another trend about tying our data processing into our online transaction processing. And I'm seeing a merger of those architectural styles to be able to combine, particularly in DevOps, our data pipes along with our transaction pipes. If you have dependencies on large volumes of data, the processing of those is starting to emerge into similar capabilities.
Okay, I'm afraid time's up. If you can ask your question in person later on. Well, Graham, thank you very much for this. I've copied it into my roadmap for the future. So thanks a lot for coming. Give him a warm hand.
Thank you.